Hey guys, I wanted to show you this project which I did about a year ago now, which means that it has been working and operating about a year now. And I wanted to make this video because I think it has pretty much proven that it works. And this is a weather station, probably you can guess. And I did it because, well, I needed some outside data, not so much temperature, but more like light and that sort of stuff that I didn't have before. So I wanted to use many different I2C sensors. So I don't remember each name, but you can see it on the screen. So I have one environment sensor, which is measuring temperature, humidity, and atmospheric pressure. And then I have two sensors up here that are measuring light, ambient light, and there is also one which is measuring UV. And I believe that's a UV A and B, but probably I'm going to check that with the data sheet, and it has a calculation, so it can also give the UV index that you usually see on the TV. And finally, I also purchased these dust sensors that gives you PM 2.5. Technically, it also gives you PM 5 and PM 10, but I mean, that is some sort of calculated value. Technically, it only really measures PM 2.5, and then it uses some calculation to derive the other two values. And I did this sensor mainly to see how I can build something which is exposed to the element, but also it is able to properly function in my climate, where we have like really hot summers, and then we have pretty much -0 degree temperatures, like -10, 15 in the winter, and also a lot of rain and snow. And what you see here, this is a PVC pipe. It's sort of in a temporary position because this part of the garden is being remodeled. So this is a PVC pipe, and these fins or collars are actually collars that you can buy to hide a place where the pipe goes into the wall. So these are collars just like you can see here. So I bought quite a few of these, and I just stack them together, and then in between you can see some drilling holes. And I think I'm going to overlay some pictures of the build process. I don't have a video of that. So obviously most of the stuff is inside, and I'm not sure if it was a wise decision, but actually it runs off mains voltage. So the mains voltage comes up here, and it has one of these HRK small transformers which gives me 5 volts, and then that powers the VMOS D1 Mini. And as I said, most of the sensors are I2C, so the wiring was really easy. It basically just have the 4 wires, SCL, SDA, the power and the ground, and that just runs to all of the sensors. And there is a separate connection for the dust sensor. And I unplugged the unit, and I'm going to freehand this now. You can see this top cover that I can lift off, and that's basically a light bulb that I broke the top of the light bulb off, and I used 2-part epoxy to maybe some hot glue as well. No, I think it's 2-part epoxy, which is starting to deteriorate. I think it's starting to delaminate now, but that's the cover, and that hides the focus. So that hides the two sensors. One is the UV sensor, and the other one is the ambient light. And probably you can see this star shape construction, and that's the 3D printed part. And the blue one further down below, that's the dust sensor. So, and at the moment, I have stairs down to the cellar, so this is not an ideal placement for this, but as I said, this part of the garden is being remodeled, so this would get moved. And to be honest, one thing I really use from this sensor now is I use the ambient light sensor, and when that detects darkness, I think I use the value 270 or below, then that's the trigger for myself to lower the blinds, which is going to conserve heat in the winter. So you see this plastic cube. I think it's a 50mm plastic cube with these colors. I actually glued them on, and I just used different type of drill bits to drill the hole, and you can see that I have holes all the way through. So it should provide good air circulation for this unit, and I was hoping that would ensure that I get, proper temperature and humidity readings. I don't think I have any issues with the humidity. That's that sounds like good humidity reading, but for temperature it's definitely showing more than what's the temperature outside. And this thing runs a custom Arduino code where I just basically read all the sensors, and I think there is a 10-second timer, and then every 10 seconds it sends me some MQTT messages that you can see on the screen. So I have temperature, humidity, pressure, I have the light intensity. It gives me light intensity and also infrared. So technically I should be able to tell if the weather is cloudy or it's a clear day. There is a UV index. There is actually a UVI value from which I calculate a UV index, and you can see the free PM values from the dust sensor, and it also gives me the single strength. So these are the values that I get out from this unit, and you can see that it gives a temperature of 29 degrees. It is definitely not 29 degrees at the moment. So yes, the temperature is going to be off, and if the sun shines on it directly, it's going to give me an even higher temperature. To be honest, I don't think it's a lot off. It has been a really hot day, so probably it's like, I don't know, maybe 26 now. But when the sun was shining on it, I think it was showing like 35. So ideally, if you want to build something like this, I think you should build like 2 units. One would have the dust sensor and the temperature sensor, and that should be placed in a shady area, maybe under a tree. And then you just have the light sensor, which obviously needs light. So you would be able to use all the measurements without having some sort of assumptions that, oh, maybe I need to treat the temperature because the unit is in direct sunshine. The only special treatment this unit got, obviously I was concerned the weather, especially because there is a main transformer. By the way, it is connected to an outlet which is protected by the GFCI or RCD. So if it fails for any reason, that is definitely going to trip before anything happens. So what I have done is I used conformer coating and pretty much coated the entire electronics and the PCB with all the connections. So even if moisture gets in, it wouldn't be able to create short circuits. So the only thing which I haven't conformer coated is, well, basically the sensors, the small chips on the sensor boards, and, well, obviously the USB connection on the Wemos D1 Mini, so I can upgrade the firmware if I need to, because I don't use OTA. But as I said, other than that, it's been working outside for the past year. It never tripped the breaker, so it's definitely not an issue for that small transformer unit to be outside in the elements. Probably, I mean, it's a very long board, probably something like that. So that's under the area where I have the holes, and it's pretty much in the middle of the whole construction. So even if there is condensation, that would probably like drip down in the side of the pipe and not on the electronics in the middle. And by the way, funny thing is that dust sensor stopped working after a couple of months, and I have given up on it. I think I was even thinking about changing the flow so I don't record a lot of zeros, it just gets ignored. But I think I didn't do that, and I was checking my dashboard a couple of weeks ago and it came back. So I don't know what happened, but the dust sensor started working again. So this is really good stuff. Let me show you what I did in the Arduino sketch in case you want to make some changes to it. First of all, let's talk about the libraries. I'm not using anything special for the networking, web server, Wi-Fi, PubSub client for the MQTT support, and the Wi-Fi. Oh, I have it twice. Anyway, and I need wire for the I2C. I'm not really sure why I needed the Arduino Edge, but probably I needed it for something. And for the free sensors, the free I2C sensors, I'm just using the Adafruit libraries. So just you can find them in the library manager and download them. So BME280, the generic sensor ones, SI1145, and the VEML6070. And here in the beginning of the code, there is a bunch of declaration where you define your SSID password, MQTT settings, and a lot of topics that the message should be sent to. And basically the way the code works is that I think it reads the sensors continuously, it stores them, and whenever the 10-second mark comes, it will send them out in MQTT. And I think I thought I've defined how frequently the MQTT is sent out, but maybe I didn't. Um, and the ESP also generates its own web server. So if you just point the IP, then you can see the current readings, and if you refresh, then the data is going to refresh. Yeah, I mean, I could have done another URL, for example, /status, where it gives you the data in JSON as well, so you can integrate it with some other systems which don't use MQTT. I don't know, maybe that would be easier to integrate it into Home Assistant if you're not using MQTT, but I think MQTT is fine as well. But you can modify the code if you want to. And oh, it is actually here. I've created this timer callback function. So there is a 1-second timer. So as you can see, it every second it counts the number of seconds it passes, and if it's 10, then it's going to send out the MQTT message, and then it resets the seconds to 0. So this is why it sends the MQTT updates every 10 seconds. So if you want less frequent, you can change it to, let's say, 60. So that would be 1 update per minute. And setup, I do the usual, setting up the Wi-Fi and the sensors and everything. And as you can see in the loop, we are just handling the HTTP server client requests, the MQTT reconnection. We are also calculating some uptime that you can see here. So how long the unit was working. So I recorded the previous segment about an hour ago when I unplugged it to show you the internal. So that was, it's been running since I plugged it back in. What else? That's the piece where it's reading the dust sensor, and from time to time, I think probably in the interrupt callback. Yeah, it's in here. So it is reading the sensors every 10 seconds as well. So the I2C sensors, and then it sends out the MQTT message. Actually, I think I should have done this. Obviously, you read the sensors and then you refresh the data and you send out the MQTT message. Anyway, so that's the version that I'm going to upload to GitHub. And yeah, I mean, that's it. And the rest is just, reading the sensor data, refreshing the web page, putting this into the serial monitor as well. And yeah, there is, that's the function for reading the PM values. Again, I've taken it from an example. So it's a really straightforward code. It doesn't do anything special. Again, GitHub link is going to be in the video description. So next thing is, if we look at the Node-RED flow, it's pretty much this one that you can see on the screen. One thing I have done with the PM dust readings is I created this chart where you can see readings. PM 2.5 is in blue, and PM 10 is in green. And the darker shades are the readings for my sensors, and the lighter shades are some official sensors from that are maintained by the state, where they are, measuring the air quality. And actually, they do have a site, and believe it or not, they have a website. And I looked at, what the website does, and actually the website calls this URL with a station ID, so you can get, a station which is around you, and that this URL is going to give you a JSON. So I can just easily fetch the data from online. So I think what I'm doing is every hour I'm getting the official data, and I'm matching that with the data that I'm getting from my sensor, and that's what is being displayed here. And I mean, I did this to sort of like tell how bad this sensor is or how good this sensor is. And you can see there is some really, really high readings, whereas the official readings was actually quite low. which I mean could be valid readings. Maybe there was some, I mean, maybe there is a construction nearby or somebody. Actually, I was also working a lot in the garden, working on some decking, so I was using orbital sander, not right where the sensor is, but maybe the wind was blowing in that direction, so I never know. But anyway, I mean, if you look at, for example, this section, they tend to sort of like, you know, follow the same pattern. So I don't think these sensors are, you know, particularly rubbish. But even though if you look at the readings, it's almost like, you know, 5 times the official reading. But that's just, you know, me playing around with the data, what I can get. And also you can see here that sometimes it goes back to 0. So I think this, you know, PM sensor is still probably on its last legs. I don't know how much they were designed to be working outdoors. So it sort of goes down to 0, and then it springs back to life from time to time. And then here it seems to be working fine again. I don't know, maybe it's related to temperature or humidity. But yeah, it has its own issues. But that's what this part of the flow does. So you can see it updating the chart here. And other than that, that's the main place where I get all the readings for the various MQTT topics. I'm saving it in some global variables, and I'm doing a snapshot every minute where I'm just saving the data in a database as well. So I'm getting updates every 10 seconds, and I'm saving snapshots every minute in my usual database. And I also used my autologger code or flow that I discussed in a previous video, and I'm also saving the data in some CSV files as well if I need to use them later, and these files get backed up to my NAS server. So that's just like, you know, data maintenance and saving data without really doing anything with it. So what I'm doing with the data, so one thing that I've already mentioned is I'm trying to detect whether this is whether it's nighttime or daytime. So it is nighttime at the moment, and I'm using the infrared value. I thought I'm using the light, but maybe I'm using the infrared value. So first of all, I just filter out anything which is 0. So if it's complete darkness, or if for any reason the sensor is not working, I didn't want that value to be considered. And I just use these, I don't use this smooth node a lot, but actually it works quite, you know, it does auto averaging with just a single standard node, so I don't have to write code. So it averages the last 10 readings just to remove some spikes. And I have a really simple function node which says that, you know, if it's a night, if it's daytime and the value is below 220, then that's what I consider as, you know, switching to night mode. And if it's night mode, but then the light value goes above 400, that is the transition to to switch to daytime mode. And in here, that's where I trigger all the blinds to go down. And I also send myself a message which goes out from this node, goes into Telegram. Yeah, very simple, and it works really good. So, I mean, you know, I'm not relying on even the dusk and the dawn settings. It really depends on the light conditions. So if it gets really cloudy towards the evening, then, you know, it might trigger earlier than the actual dusk setting. But I think, yeah, probably dusk would be fine as well, but I thought I'm going to use my sensor to trigger my automations. And the other thing which I'm also doing, which actually has never worked, and I don't think I've debugged this flow, so I might have made some programming mistake in here, but maybe my assumptions were just incorrect. So this triggers every 10 minutes, and this function node is, it logs the temperature, the humidity, and the pressure readings in a variable. And it basically, you can see it here, it's this weather history. So if I update, you can see that it has pressure, temperature, and humidity, and it always has 6 values, or up to 6 values. So it cycles the last 6 values And because it's triggering every 10 minutes, it means that it contains the values for the last hour. And what I try to do is, maybe I can give a, well, I wouldn't say early morning, but because probably that's going to be like a late morning if a storm comes. So if I have 6 readings, so if I have a history for an hour, then I'm going to compare the reading ID 0, which is the last reading, with the reading 5, which is the one hour ago. And if the difference is more than 4, so these are pressures. So if the current pressure is more than 4 hectopascals less than the pressure about an hour ago, 1 hour ago, then that means that the pressure has dropped significantly within an hour. So a storm is probably coming because there was a pressure drop. And my idea behind this flow was something that I have on a like a small like an RF weather station, because that has a configuration that if the pressure drops more than 4 hectopascals, then it can send like a storm alert. Something just flashes on the screen. It doesn't say the time interval for that pressure drop, so I thought maybe 1 hour is going to be fine. So that's what he's doing, and it never worked. So we get quite a few storms in the summer, but it never triggers. And also, if I try to do, maybe, it's pressure is not good, maybe I should try with temperature. So it does the same thing. So I'm comparing the current temperature to the temperature 1 hour ago, and if the difference is more than 10, then maybe the temperature is dropping because there is a storm coming. So again, I can send myself a storm alert because there is a temperature drop. So not sure if there is a logical error in this code, but it just doesn't work. I never get a message. And I don't think I have, maybe I should spend more time to investigate this. And that's the end of the flow. So this is how much I have done with all these readings so far. As you can see, most of it just gets stored in a database, not really doing anything with it at the moment. Maybe I should do, I don't know, maybe you have some ideas how I can use some of these readings to trigger some automations at home, or how you would use them. Just leave your ideas in the comment section below. So that was the flow and a little bit of the UI. I actually don't have any other UI for the rest of the data. It's not being shown anywhere else, just other than this small MQTT Dash application on my phone, which I have shown in the beginning of this video. Okay, so I think that will be all about this weather station. If you are interested in this project, you can find the link to the sketch in the video description. I'm also going to leave the 3D design file, but of course if you have a different diameter pipe, you just have to change that. But otherwise it's not a complicated 3D printed part. So that will be all for today. Thanks for watching, and hopefully see you in the next video.